Hi everyone. So to help out with the topics of law of sine and law of cosine, I've picked out one of the problems I get a lot of questions on, which is surveying and navigation problems. So the first thing we need to do is draw a picture of what this description is talking about. So we have a starting point. I'll put it right about here. Now it says, from an iron post, which is what we'll call that, proceed 500 meters northeast. So what we're going to do, I usually draw in these tiny little north-south lines, any place where you're starting or changing direction. So going 500 meters northeast, well, northeast is going to be exactly 45 degrees in this direction. So let's call that 500. A length of 500. And the thing we can mark too is that this angle is 45 degrees. Okay, now it says then go 300 meters east along a brook. So from here, and let's draw in another north-south reference line, we're going to head directly east for only 300 meters, and you can try to get the lines relatively to scale so that the 300 looks smaller than the 500. Okay, then the person is going to switch directions again. It says then 200 meters south, 15 degrees east. Well, let's get our north-south line in here. So the south 15 degrees east means from the south they're going to rotate 15 degrees towards the east, like that. So this little angle right in here, measured from the south, going towards the east direction, is 15 degrees. And then they're going to go along that for a distance of 200 meters. Let's make that a little bit longer. So this right here is 200. And then finally, they're just going to return back to their starting point. So from right here, they're going to return back to their starting point. So I probably, to do what I said, I should probably draw a north-south line there also. Now the question is asking us to find the total area enclosed by this figure. So one thing we need is triangles. I'm going to choose to draw an extra line from here to here. And I'm going to try to find the area of this triangle first. Now there is a new formula that you probably learned, that the area of a triangle is 1/2 AB sine of C. And that just means it's 1/2 times, this is any two sides, but this right here has to be the angle between them. So angle between the two sides. Alright, so I have the 300 and the 200 already. That's a good starting point. So I really just need the rest of the angle next to the 15. So I need this part. And because that was connecting a line that was directly east down to a line that's heading south, that's exactly 90 degrees right there. So what that means is that total angle, I'm going to try to erase and combine this. So that means that this total angle right in here is 90 plus 15. So that'll be a grand total right here of 105 degrees. So that triangle is going to have an area of 1/2 times 300 times 200 times the sine of 105 degrees. And you can just do that in your calculator. And that ends up being equal to 28,977.8. Now we need to find the area of the other big triangle. One thing that we could do though is find the length of this side right here because it's a side of both triangles. Now, I could find the length of that side by doing the law of cosines with these numbers using the 300, the 200, and the 105. So I'm going to be using those again. So the law of cosines would say that x squared equals 300 squared plus 200 squared minus 2 times 300 times 200 times the cosine of the included angle, which is 105. And that, again, we can do all on the calculator. And I just did that, and it gives us x equals 401.3. So that's the length of, I'll erase the x, it's just the length of this side, 401.3. All right, now our goal is to find the area of this bigger triangle down here, which we're doing good so far because now we have a side right here and a side, I can't highlight it, but the side that we just found, 401.3. So now we have to find this angle right there in between the two sides. Well, the other thing you can use in these pictures is alternate interior angles, which is from geometry, and that's why I drew in all of those different north-south lines. Let me erase a little bit of this highlighting so you can see it better. So what we're going to do is follow this north-south line, follow this side of the triangle down to that north-south line, because if you can find a Z shape, I always call it, then the two angles in the little corners of the Z will be equal. So we know that since this one, the first one was 45 degrees, this over here is also 45 degrees. Now the only part that we don't know then, because we don't know that whole entire angle yet, so 45 is only that part, we need to find this angle. Now what I'm going to do is actually find this angle in that triangle, because together those two angles would form 90 degrees. So that angle I could find by doing the law of sines. Let's call that theta. So I'm going to solve for theta using the law of sines. So I could say sine of theta over 200 equals the sine of 105 over 401.3. And then I can cross multiply and solve for theta. I'll do that on the calculator. And that ends up giving us theta equals approximately 28.8 degrees. So that's that theta right here. I'll erase the theta and write the degree in that we just got. So that's 28.8 right there. Now the thing is, we do know that this is a right angle. So if I just do 90 minus 28.8, that'll give us the part of the angle that we really wanted. So let's do that. That gives us 61.2. Okay, and where that's going to go is, just clean up our picture just a little. The 61.2 is going to go right there. All right, so now the nice thing is we can combine 61.2 plus the 45 degrees, and we can get that whole entire angle. That's going to be 106.2 degrees. And see, that's going to go stretch from here over, let's undo that, sorry. That's going to stretch from here over to there and be 106.2 degrees. Alrighty, now we did all of that so we could find the area of that big triangle. So I'm going to use that area formula that I wrote down before, and area of the bigger triangle is going to equal 500, it's going to equal 1/2 times 500 times 401.3 times the sine of the angle between those two sides, which is the 106.2 degrees. And we will just do that in the calculator. So that comes out to a total of 96,341.5. And I'll just show, so this area is for this triangle right here. And the area that we wrote down over here was for this other triangle. So we have the yellow triangle and the green triangle, and all we have to do is add together the two areas. So I'll just do 96,341.5 added with 28,977.8. And I did that on the calculator already, and that equals approximately 125, so 125,319. That's just rounded, and meters. So this is area, so this would be meters squared for your final answer. So this is just one of the more complicated problems where you have to use, we ended up using the law of cosines together with the law of sines, together with the new area formula that they usually teach you right around that same time that you learn those laws to find the total area of this figure.